we're trying to express this sum, which we have the first term and then a second, third, and then whatever the final term is in summation notation. So summation notation uses this Greek letter sigma, and we will start, K is usually the letter used here. It really doesn't matter as long as you're consistent, and we'll say K equals 1, which means we're just starting with the first term. It's really like N equals 1, 2, 3, etc. So I'm going to write above this K equals 1, 2, 3, ... and we need to figure out what that last one is. So if we look at the first, second, third term, for a pattern here, you can see that they all have x raised to some power. Well, this is x to the first, x squared, x cubed, so we have x raised to the power of k. And then in the denominator, we have multiples of 3. Well, 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, so this is really 3k. And that process is the same as when we were determining the sequence in the examples right before this. Well, if we now look at this x to the 10th over 30, we need to say how many terms did we really go out to here? Well, to get x to the 10th, k would have to be 10, and if we check that in the denominator, 3 times 10 is 30, so that means that we are adding up 10 terms here, and that number on top of sigma represents how many terms. So that is summation notation, and this would say, you know, each of the pieces here, you're starting with your first term, you're going to your last term, and then that is the rule that gives you the different terms in that series.